Right, in this chapter, you will learn about the cosine rule. Now, let's do a bit of a recap. So you have learned about the sine rule. Okay, the sine rule is let's say a over sine of the opposite angle A is equals to b over sine b equals to c over sine c. All right, now let's consider this scenario where you have a triangle, and then let's say this is the point A, so that's a side A, this is a side B, and that's a side C. Let's say we know this value of C is equals to 13 centimeters, or whatever the unit is, 13, and B is 10. Actually, maybe I should swap around, it will be 15 here. And the angle A is roughly 40 degrees. Okay, let's say we know this information here. Can we use the sine rule to solve this? Well, let's try the opposite side. A over sine of the angle A, which is 40 degrees, equals to, choose any of the side. Let's say B is 15. The question is, do we know sine B? Well, we actually don't know the value of the angle B. We don't know what this angle is. So you can actually use sine rule to solve this triangle. And to save the day, here comes the cosine rule. Okay, so for this triangle, you need to use the cosine rule, and here is what it is. The cosine rule says that if you have any side A, so A squared would be equals to the sum of the square of the other two sides, B squared plus C squared, and then you have to subtract, right, 2 times by the two sides BC, and then times by, well, it's called cosine rule, so it will be cosine of the the opposite angle A. Alright, now let's see how we can use this to solve this triangle. You would have the sides C is 13, so we don't know what A is, so we'll just leave that. A squared equals to B squared is 15 squared, and then C squared is 13 squared, minus 2 times B 15, C 13, and we do have the angle A. Cos of A is 40 degrees. So look, now we have got an expression for A with all of these numbers. You can just punch this whole thing into the calculator, and then you get A squared. So then A is essentially square root of that entire thing. Okay, positive square root. So that's how you would use, and this is called the cosine rule. The cosine rule. Okay, so that's how you would use the cosine rule in this case. So note that you can actually write different versions of the cosine rule. So some other variations would look something like this. Let's say if you have the side B instead of A, so just remember B squared would be the sum of the other two sides, so A squared plus C squared, and then minus 2. Now instead of having BC here, you would just have the other two sides, which is AC, right? And then times cos of always the angle that the opposite angle that we know, so cos of B. And similarly, you get C squared equals to A squared plus B squared minus 2AB, and then cosine of the angle C. So that's capital C. Yeah, this is the lowercase c. All right, so these are the variations of the cosine rule. Let's have a look at some examples now. All right, in example A, so let's see, we actually have a side, and then right, I forgot to mention, how do we identify when to use the cosine rule? Well, you can use the cosine rule when you either know 3 sides, or you know 2 sides and the included angle. So what's an included angle? The included angle is the angle that is created by these 2 sides. So you see, the 10 and 15 meter sides, it will create this angle 15 degrees. So this is the included angle. Okay, so if you have 2 sides and the included angle, you can use the cosine rule. Now, let's use the cosine rule here. So we have the opposite side, so x squared would be equals to the square of the other 2 sides, 10 and 15. So you don't actually need to know what's A and what's B, just remember the other 2 sides. And then minus 2 of the product of those 2 sides, and then cos of the included angle 50 degrees. All right, punch it into the calculator and you get your answer. So x would just be square root of that whole thing. And it will be the same for question B here, right? So for question B, x would be square root of a really long thing. That would be the sum of the squares of the other 2 sides, minus 2 times their product, and then cos of the included angle. Okay, and that is it. All right, now let's try a problem solving question here. A tower at A is 450 meters from O. Okay, so from O means let's draw it in the middle. So O is here, and from O means I need to draw the north line from O. all right, on a bearing of 340 degrees. Now, roughly where is 340? So we know that the first quadrant will be 90 degrees, the second quadrant will be 180 degrees, and remember, the bearing is always clockwise, right? And then at the end of the third quadrant will be 270 degrees, so 340 is near 360, it's actually 20 degrees away from 360 degrees. So actually we can quickly do that calculation, and we'll put here as 20 degrees. So this angle here all the way to this point would be 340 degrees. That's true bearing from point O. And then the tower at A is 450 meters. Let's say we'll put A here, and then we know this side is 450 meters. All right, and then tower at B is 600 meters from O as well. So we will use the north line from O again on a bearing of 60 degrees. Okay, 60 degrees is roughly around here, or maybe a bit more than that. Let's say around here. So let's say B is here, and 600 meter is a bit longer than 450. So that will be 600, and this angle is 60 degrees. All right. Find correct to the nearest meter the distance between the two towers. So this is point B. We want the distance between them, which is the line AB. Sometimes in the drawing it may look too complicated, so you might want to redraw the main triangle that you want to work with. In this case, the triangle AOB. So I'll try to copy that triangle somewhat over here. AOB. Now, do we know anything? Well, we know OA is 450 and then OB is 600. Do we know the angle in between? Yes, we do. It's actually just the sum of this angle plus this angle here, which is going to be 80 degrees. All right, but we should write down the working anyway. So angle AOB is equals to 20 degrees plus 60 degrees equals to 80 degrees. And we did a quick calculation for the angle AO, and we use a north line. Let's put a point X here. So we will write angle AOX is equals to 360 degrees minus 340 degrees, which is 20 degrees. All right, let me shift all these workings down a little bit. All right, and rewrite the 20 degrees. Okay, so now we can use the, in this triangle here, we can see that we have the two sides and the included angle. So that's the cosine rule. So using cosine rule, all right, we should write what we're trying to do here. Using cosine rule, we'll have AB squared is equals to the square of the other two sides. So 450 squared plus 600 squared minus 2 times their product, and then times cosine of the included angle 80 degrees. You can choose to punch that in first, but I prefer to write it as in one step, and then I'll punch the one big step into the calculator. I will cheat a little bit here and copy paste this. It will go somewhat like that. So yes, if you punch this entire thing into the calculator, you get the answer, which should be 684.63 to 2 decimal places, and the unit is in meters. So that's the distance between the two towers using the cosine rule. All right, make sure you try out the examples before you get to the exercises.